Hello everyone, my name is Hardeep Singh and today again we are taking some more questions of JEE mains which came in session 1, that is January 2024. So these questions are from shift 1 of 27th January. Let's see what is this question. This is a question based on differential equations. So we have x equal to xt and y equal to yt. These two are functions which are solution of these two differential equations. So what we do after that, given that x0 is equal to 2, some conditions are given. After that, more conditions are given. Then they are asking find value of t when xt is equal to yt. So basically first we have to find solution of these two differential equations, apply some conditions, then check for this condition. Okay, let's try that. So we have this given thing dx by dt plus ax equal to 0. We are using variable separation here. So this becomes 1 upon minus ax dx equal to dt. Variables are separated, we are taking integration here. It becomes minus 1 upon a outside, you can write ln x, which is equal to t plus c. Now there is some condition given for this. They have given when you put x equal to 0, you will get equal to 2. When you put t equal to 0, you will get x equal to 2. So I'm substituting t0 here, x equal to 2. So it will be minus 1 upon a ln 2 equal to 0 plus c. So c is equal to minus 1 upon a ln 2. Now substituting back in the given equation, we will be getting our solution as minus 1 upon a ln x equal to t minus 1 upon a ln 2. So taking this value on the other side, we get minus, let's say 1 upon a ln 2 minus 1 upon a ln x equal to t. This becomes 1 upon a ln 2 upon x using properties of log equal to t. We can write it as ln 2 upon x equal to e raised to power at. Not e raised to power at, only at. Now taking exponential on both sides, we get 2 upon x equal to e raised to power at. Or we can say x upon 2 will be equal to e raised to power minus at, and x is coming equal to twice of e raised to power minus at. So this is the solution that we got for x, function x. Now similar thing we are doing for the other function, which is given as dy by dt plus by equal to 0. Now to solve this, we are again trying to separate the variables. So taking this term on other side, now what we do, we bring it on this side equal to dt. Variables are separated, we can take integral now. So 1 by minus b is just constant, we can write ln y here. Here it will be t plus c. So now this is the general solution of a second differential equation. We can apply the second condition here. Here they are saying that if you put t equal to 0, y will be 1. So we are applying that here. T equal to 0, y will be equal to 1. So when you apply it here, ln y, that is ln 1, 0 plus c. So ln 1 is 0, so c is 0. We substitute it back in the general solution. So we get it 1 by minus b ln y equal to t plus 0, which is just t. So this becomes ln y equal to negative pt. Taking exponential here, we will get y equal to e raised to power minus pt. So up to here we got two solutions. One is this one, other solution is this. We will use these two in the next condition, which is 3y1 equal to 2x1. Let's take it. So another given thing is 3y1 is equal to 2x1. So now what we do, 3 times in function y, in place of t we are putting 1. So it will be e raised to power minus p, twice of, so here we have twice of e raised to power minus at, so it will be twice of e raised to power minus a, because value of t is 1. So this becomes 3 e raised to power minus p equal to 4 e raised to power minus a. This comes on this side, we can write 4 upon 3 e raised to power minus b upon e raised to power minus a. So when we take it on, we apply the laws of indices here, it becomes e raised to power a minus b equal to 4 by 3. That's it. So now this is what we got after applying the third condition. Now they have asked here that you have to find the value of t when xt is equal to yt. So we will just equate these two and try to find the value of t. So another thing given here, given xt is equal to yt, the value of xt is given here. We have found it twice of e raised to power negative at is equal to value of y is e raised to power minus pt. So when we equate this, we can bring this one on this side, it will be twice of e raised to power minus pt upon e raised to power minus at. So using laws of indices, it becomes e raised to power at plus bt, at minus bt. So this becomes e raised to power a minus b times t. This is what we got now. So what we can do, we can put the value of e raised to power a minus b, which is 4 by 3. So we can write 2 4 by 3 raised to power t. To simplify this, we can take ln on both sides. We can take log with base 4 by 3. So this will be the value of t. This is the final answer for value of t. Let's see if we have this option. Yes, so option number 4 is our right answer. So this question was a bit lengthy, but you will see in the previous year questions, whenever a question comes from differential equations, it is very straightforward, but it can be the case that most of the times you will get a lengthy question of this chapter. Let's take next question now. So the next question is on a bit of geometry and integrals. Let's see what it is. If a comma b is orthocenter of a triangle whose vertices are given here 1 comma 2 2 comma 3 3 comma 1, and there are two integrals I1 and I2, we have to find 36 times I1 by I2. What will be the value? It means we need to simplify these integrals, but if you notice these values, definite integral is having some limits here. These limits are actually the coordinates of orthocenter. To solve these two, we will need the orthocenter first. So starting with that thing here. So let's draw the triangle first. We are roughly drawing the triangle here. Point A 1 comma 2, B is 2 comma 3, let's say C is 3 comma 1. Now what is orthocenter? Orthocenter is point of intersection or concurrency of the altitudes of triangle. So what I do, I can just draw the altitudes here, find the equations of the altitudes of triangle. After finding the equation, we can find the intersection point, which will be orthocenter. That is, we can find value of A and B. So let's try that. Let's call it CM. So to find equation of CM, we will need the passing through point and gradient. Passing through point is already given. For gradient of this line, we will use gradient of AB and take a negative reciprocal of it, because that's the relation between the gradients of two perpendicular lines. So starting with that thing, let's write here gradient of CM. Gradient of CM will be equal to -1 upon gradient of AB. So this will be -1 upon, we are writing gradient of this, or you can say slope of this, 3 minus 2 upon 2 minus 1. So which is coming equal to -1. So this is the slope. Now what we do, we can write equation. equation of Cm. Equation of Cm will be y minus y1 equal to gradient x minus x1. So this becomes y minus 1 equal to minus 1 x minus 3. So y minus 1 equal to minus x plus 3. So this becomes x plus y equal to 4. So that's the equation of the altitude Cm. Now we can find the altitude Bn maybe. After that, what we do? We can find their intersection, which will be value of A and B. But if you look closely here, when we apply property of integral here, we will be writing A plus B minus x. It means basically we need value of A plus B, not individual A and B. So you can directly say here that orthocenter A comma B lies on this line. So we can put coordinates of A and B here. It will be A plus B equal to 4. So this is the result we got, and it will be useful to solve these. We don't have to individually find values of A and B. Let's see how. So first we are solving integral I1 A to B x times sine 4x minus x square dx. So we have this property which can be applied here. A to B fx dx is equal to A to B f of A plus B minus x dx. So applying that property here, what we get? We get I1 equal to A to B. Here A plus B minus x sine of 4 times A plus B minus x minus of A plus B minus x whole square dx. Now substituting the value of A plus B, which is 4 here, so we can write A to B 4 minus x sine of 4 times 4 minus x minus 4 minus x whole square dx. So after this, what will happen when you open it? When you open these brackets, actually you will get the same thing here, 4x minus x square. So now what we do, we can separately multiply inside here. So I'm multiplying inside. So I1 is equal to A to B 4 minus x. So it will be 4 sine of 4x minus x square dx, negative of A to B. Now I'm multiplying with this value minus x. So it becomes x sine of 4x minus x square dx. So when we go back here, we see that this is actually I2. So this can be written as I2 here, minus I2. And here I1 equal to this value. Let's see what is this value now. This value, no, actually this value is I1. This value is I1. And this value is I2, which can be used here. So this becomes 4I1. I2, I guess. I2, yes. So this comes on this side, it will be twice of I1 equal to 4 times I2. So I1 by I2 will be equal to 4 divided by 2, which is 2. But we need the value of 36 I1 by I2. It means we will multiply 36 on both sides, which is equal to 72. So answer should be option 1. Let me tell you again. So what we did, basically we needed to solve these two and then find the ratio. While solving these, we know that we will be needing value of A plus B, not individual A and B. So what we did here, we found equation of one of the altitudes, and luckily it was coming in this form that x plus y equal to 4. So if we just substitute orthocenter in it, which should satisfy this equation because it is lying on this. So when we put it here, we got A plus B equal to 4, and it was useful while applying the property to solve this integral. That's it. So I hope this question was easy for you and you understood everything. We will take more questions in the next one. Thank you.